much. Thanks, Anthony, and thanks to MSD for inviting me to do this webinar tonight. So I'd like to talk to you this evening about equine neonatal sepsis, which is one of the most common problems we deal with in equine neonates. So this is what we're going to run through briefly this evening. We're going to think a little bit about the causes and risk factors for sepsis. We're then going to think a bit about the pathophysiology, clinical signs, recognition and diagnosis of sepsis, probably most importantly the treatment, and then probably even more important than that, the prevention of sepsis. So that's sort of a brief synopsis of what we're going to run through this evening. So slightly disappointingly probably, considering how far equine neonatal medicine has gone on, sepsis does remain the leading cause of mortality. And when you think about all the different conditions that neonates suffer worldwide, then sepsis still will come out to be the leading cause of foal death, which is a little bit disappointing considering the advances we have in neonatal care and medicine and antibiotics, etc. But there are reasons why this is the case. Foals are actually inherently not that well designed to be protected from sepsis, especially in that very early neonatal period. And these are the major reasons why they're inherently at risk, because they're born in this A-gamma globulin anemic state, meaning they rely heavily on the colostral transfer of antibodies. They also have a relatively immature immune system when they're born, and due to the need of colostral absorption of antibodies, they have this open gut system which allows pinocytosis of globulins into the circulation. And as a side effect of that, that can also allow direct access of bacteria from ingestion in the mouth directly into the circulation. So for all these reasons, sepsis is a real problem in foals. So just to start sort of background to that, we're going to think for a few minutes about the neonatal immune system and how that differs to the immune system in an adult. And fundamentally, when we think about it, the immune system is all present in a foal, so all the components are there, but they are not all working quite to the same level as they would do in an adult horse. So when we think about that, what we consider is that these foals are immune competent, but basically immune naive. And although all the components are there, that the function of them is less. So if we think about that, splitting that up into the different parts of the immune system, we think about the different components of the immune system. We break it down into innate immunity, which is the non-specific immunity, which relies on complement, phagocytosis, natural killer cells. And then we think about the other part, which is obviously lymphocyte production of antibodies, and then the use of T lymphocytes to make cytotoxic T cells, which will kill cell-mediated bacteria. So we think about these two components of the immune system separately. We'll start with the innate immune system. Well, actually, foals, although they have fundamentally a mature innate immune system, they're born with a much lower level of complement activity. So if you compare the complement activity of a neonatal foal in the first day or two of life, that's only about 13% of an adult value. And that means that this has a big end-on effect. It reduces neutrophil chemotaxis and reduces phagocytosis. And that's another reason why when we think about the importance of colostrum, it's really, really important, because complement is absorbed in the colostrum, so it's not just globulins, complement's another important part of that. And that's really important in improving the foal's ability to use opsonization and phagocytosis. So even though we think about globulins as being the most important part of the colostrum, actually the complement and other factors in the colostrum have a really important role at improving the foal's fundamental innate immunity as well. So what about adaptive immunity too? So if we look at just the number of lymphocytes and the ability of these lymphocytes to proliferate, they're actually fairly similar in a foal compared to an adult. But there is definitely some differences in the way that the immune system functions. When we think in very broad terms about generating a Th1 or a Th2 response, with a Th1 response being the cell-mediated response, which is very important for treating and killing intracellular organisms, we think of foals as being slightly more prone to generating a Th2 response. That's some sort of response you might also associate with allergy and that sort of thing, and that's not so good at killing intracellular organisms. And so in foals with sepsis, if they are producing more of a Th2 response, that's definitely less effective at killing microbes and intracellular organisms. So again, that's another important part of why foals are fundamentally a bit more prone to sepsis. We've talked already a little bit about globulins, but we all know this, that the structure of the equine placenta, you see on the left, with this epitheliochorial placentation, means that the foal gets no direct transfer of globulins during gestation. And so these foals are born in a gamma globulin anemic state, And so although they're technically able to mount a primary immune response, there's a 2-week lag phase, which means that they are not really able to produce a significant number of antibodies in that 2-week period. And so without that maternal transfer of globulins via the colostrum, they're really at a high risk of infection. And that's why failure of passive transfer is such an important factor in neonatal sepsis. So again, we've touched on this already a little bit, but colostrum is vitally important when we're talking about sepsis, and not just for the role of immunoglobulins, so IgG is the one we think about most commonly, but also IgM, which is important for mucosal immunity, and IgA, but also because of the other vast array of things it has. We've talked about complement, but in addition to that there's also cytokines, there's a number of hormones and growth factors. Lymphocytes also may be important in helping the foal mount more of a cell-mediated immune response, and also a variety of other enzymes which are important. So colostrum, in terms of the role of prevention of sepsis, cannot be overestimated. And then that leads on to how colostrum is absorbed, and it's this amazing process of pinocytosis where the foal is born with these special enterocytes which non-selectively absorb molecules. So they pass via the intracellular space into the lacteals, into the circulation, and so about 4 to 6 hours after they've been ingested, you're able to detect molecules which have gone via the gut into the circulation. And the reason why this process is time dependent is because these enterocytes, these gut cells, have a rapid turnover, which means that when these initial cells have kind of expired, if you like, that the gut then becomes closed and this process can no longer carry on. So the process is really most efficient at birth, and I also think this is quite an amazing fact that by about 3 hours of age, the foal's absorptive capacity is gone down to about 22%. So it's really important that these foals are getting good quality colostrum shortly after birth. And then we're thinking about measuring IgG levels, which is just the kind of marker that we've chosen. So we recognise that all the other factors of colostrum are important, but we use IgG as an easy to measure marker of colostral transfer, but that peaks in a normal foal about 18 to 24 hours of age. So failure of passive transfer will remain one of the major risk factors for neonatal sepsis. And there's obviously been a number of studies looking into this, and if you look at extensively managed herds and foals that are born out in fairly extensive situations without that much management, there's a very strong association between the failure of passive transfer and non-survival. And that's just mortality in general, and also in terms of developing septic complications like septic joint, septic fasciitis, for example. If we look at more intensively managed populations, so for example the papers that came out of Newmarket, they found that association was a little bit less clear-cut, and that certainly in foals that had failure of passive transfer that was recognised and treated, there was not the same association with non-survival. But I think irrespective of all those things, that we frequently recognise that failure of passive transfer, so the failure of these foals to be given or to absorb maternal globulins, is a real major risk factor for sepsis. This is a really old study, but I just think it really highlights the importance of this. So this is a study that did back in '93, which they looked at the importance of colostrum deprivation. So they had 8 foals that were born normally, and they were in a sort of a scientific type environment. So they were in a clean environment. They weren't exposed to any particularly virulent organisms. They were handled in a hygienic fashion, and so 8 of these foals that were deprived of colostrum from birth were given perfectly adequate nutrition with milk replacer, and 7 out of the 8 of these foals developed signs of sepsis. If they looked at the blood cultures, they had 5 of the 7 of them had blood culture positives, and they grew a variety of bacteria, the sorts of bacteria that we normally associate with foal sepsis, Lactobacillus, E. coli. And despite fairly intensive treatment, 4 of the 7 of these foals died. And so, although I know this is the extreme situation, it's a fairly old study now, I think it really does highlight the importance of colostrum in terms of gut closing, providing immunity, and preventing sepsis. So then we come back to talking about failure of passive transfer. What is the ideal IgG concentration? And we always come back, historically to this fairly arbitrary measure of considering that a foal that has an IgG of over 8 grams per litre or 800 megagrams per deciliter as having excellent passive transfer. And I think everyone would probably agree that would be the ideal situation. And if you measure the IgG from a foal that's had good quality colostrum, it will frequently be much higher than that. We then have this kind of grey area in the middle where sort of 4 to 8 or 400 to 800 megagrams per deciliter of IgG, and we consider that a partial failure of passive transfer. I think this area is a lot grey.